Hello, this is Gerard Josh, and welcome to Fake Fox News at 4. Thank you for tuning in, because we have a special lineup for you today. We're sure that you'll get a reaction from it. We'll head over to our top story of the day with our surprise special guest from the All Safety channel, Kristen Nelson. Hello, thanks for having me on Fake Fox News today. We have a special report on a recent breach of lab safety in Plato, Texas. We haven't seen anything like it in years. During a lab experiment about acid testing rock formations, a light splash of acid was spilled onto the arm of a chemist. In his panic to rush over to a chemical shower, he slipped and tore his ACL. Guess that shows that calm and orderly is the best way to handle any situation. Now, we'll head over to our on-field reporters, Steve Stevenson, along with Rob Boss. Thank you.
Steve Stevenson here with Rob Boss, safety expert, and today he'll be telling some recent breakthroughs.
Alright, first off, and this will shock you, wearing personal protective gear will actually keep you safe in most experiments you do. This includes items such as goggles to shield your eyes, aprons to prevent skin contact and staining, and gloves because you probably shouldn't pour acid on your fingers. Even if you look stupid, it's important, but there's also another type of safety equipment, features located around the room. Let's see some examples.
This absolute unit will remove toxic fumes in the room when turned on, and it's called the fume hood. In case you decided to use bromine as eye drops or shower in hydrochloric acid, these two contraptions could save you a lot of trouble. In an accident involving your eyes, you'll have to use the eye wash station for a whole 20 minutes, time you should be spending doing your chem homework. If over 40% of your body gets covered in chemicals, that's 20 minutes in the safety shower. And we aren't done yet. Fire safety! Remember the 4 types of fire extinguisher. Class A's are used for ordinary combustible materials, such as cardboard. Class B's are used for liquid fires. Class C's are used for electric fires. And Class K's are used for oil and fat fires, usually in a kitchen. How exciting! The acronym PASS tells you how to use these proof cylinders. It stands for pull, aim, squeeze, and sweep. Next, let's talk about symbols. If you can't read pictures, you might be a vegetable, but if you can, here's the deal. Symbols will quickly tell you the dangers you might encounter and procedures you should take when doing a lab. Now for some examples. This symbol means you need to secure your loose hair. And this symbol means you'll probably have to deal with some sharp objects. So you get the idea. You're probably sick of me, so here's my last topic, identification sheets. The NFPA 704 hazard identification diamond will tell you if a substance is flammable, its health risk, its reactivity, and its special hazards. Now, there's another thing called the safety data sheet for chemicals, and it will tell you everything you need to know to stay safe. This includes properties, hazards, accidental procedures. There's plenty of stuff. Remember to read that before handling a chemical in any lab. Remember to stay safe.
Interesting. Over to me. I'm here with Rob Boss's twin, Bob Ross.
Thank you. I'm about to give you some basic procedures for some generic accidents, so hopefully you don't melt your face. If there's a chemical spill, you'll need to tell the teacher. Possibly use a fume hood and even use a body or eye washes. If it is serious enough, you may even need to evacuate the class. If there's a fire in the room, definitely tell the teacher. Utilize the classroom fire extinguisher or fire blanket and possibly evacuate. Finally, if a student gets sick, guess what? Tell the teacher. Additionally, have someone get the nurse, and if it's severe enough, call 911. Sometimes, something may even happen to the teacher. In that case, you should already have given a few people some assigned tasks. Remain calm and try to do the same procedure as you usually would.
Next up on Fake Fox News, we have a student who attends Plano East Senior High School who claims that his entire class failed the math portion of the chemistry test.
Right, apparently during the last chemistry test, over half the sophomores failed the math skills portion. This caused quite an uproar among the students and their parents, and many students wonder why they were so unprepared for the test. I'm here with Tiny Tim, who's going to try and explain what happened to cause so many students to fail. How are you doing today? I heard you have some trouble with your chemistry math skills.
I'm doing great, but yeah, math skills is a struggle. We just don't understand how to use sig figs, scientific notation, or how to convert from units of measurement, or any of that stuff in general. On the last test, I missed all the questions regarding how to measure liquids in a graduated cylinder. Chemistry is so hard.
Well, golly gosh, Tiny Tim. I can help with that, but I do know someone who can.
Who?
Well, Donnie Tim, after this, we can have a very interesting interview with Nilbai, the chemistry man.
That's what you consider interesting?
Yes, sir.
Hi, I'm Professor Nilbai, and I'm here to explain basic chemistry math skills because apparently you guys are all so bad at it. First off, we'll start off with the SI system, which is the most common system of measurement around the world. And this includes units such as grams, meters, seconds, Kelvin, moles, and liters as well. The prefixes to these units are also very important. For example, adding mega before multiples of 1 million, and on the other hand, adding milli, which is multiples of 0.1 thousand, or thousandths. There are plenty of these, so make sure you study. Next, we have a special thing called scientific notation, and we have an example set up here. It's pretty simple. This is a way to abbreviate very large or small numbers. Generally, it's written as a single-digit number with 2 decimals multiplied by a 10 with an exponent, shown right here. Now, the exponent is very crucial, so make sure you practice. 2 more things. Accurate versus precise. What's the difference? Well, honestly, no one can tell, but apparently there is. Precision is basically consistency, or how an exact measurement can be reproduced. Usually, it's limited by the smallest tick mark on a measuring tool. Accuracy is even easier. It's how close a measurement is to the real value. Usually, it's seen as percent error. Now, next, always remember when you use percentages, you must round to the hundredths place. Now, the last thing we'll be talking about are significant figures. And since we all hate them, I'll try to go through this one pretty quickly. So, first, significant figures are digits of numbers that are used to express the required degree of accuracy. And we'll go over the basic stuff. Non-zero numbers are always significant and leading zeros are not. And sandwich zeros are significant, but trailing zeros are only significant if a decimal place is present. For example, this does not have a decimal place, therefore these trailing zeros are not significant. A lot of the time, you'll be calculating using these numbers, so here are some easy rules to remember. If you add or subtract the numbers, round the answer to the same number of decimal places as the measure with the least decimal places. If you multiply or divide, show your answer with the same number of sig figs as the measure with the least amount. And that is it.